Okay, so as we were saying, titration is an experiment. And I tried to sketch out the best way I could what our experiment would have looked like. The first thing is we would be working with a piece of equipment called a burette. Burette, which is a long skinny tube, and the goal of the burette is to measure volume, and really precise volume. You have to watch the meniscus, and you'll see it in the virtual lab. So we would have had two burettes, one filled with hydrochloric acid with a known molarity of 0.1. 0.1. Leading zeros do not count. That's one significant digit. We would have consistently used the same volume of acid to be 10.0 milliliters. Decimal present, 3 significant digits. And we would have had an Erlenmeyer flask here capturing the 10 milliliters of acid. We would have put some water in there to expand the volume. And then, of course, the 3 or 4 drops of phenolphthalein, which would have remained colorless here because it's in acid. So that would have been our prep. We would have prepped the 10 milliliters of acid, the known concentration of the acid to be 0.1 molar, and we would have had the acid base indicator phenolphthalein in there, which would have been colorless. Then we would have taken the Erlenmeyer flask and put it under the base burette. And we would have had a starting volume, let's say 0.00 milliliter. We would have had to have watched the meniscus. And we would have titrated, and looked for the change in volume that would have occurred. So this would have been the change in volume. So I'm going to put delta, meaning change. The change in volume of the base that would eventually have caused this whisper of pink. And that would have been the indication that the hydrogen ion concentration is equal to the hydroxide ion concentration, and as a result, we'd have the neutralization or the end point. Okay, so now what's the data? The data is the volume of the base. That's what we were looking for. What was the volume of the base that it took to neutralize the 10 milliliters of the 0.1 molar acid? So now I'm going to show you the mathematical relationship that occurs when we have titration. And this mathematical relationship is a little bit of a blast from the past in terms of solutions. We have the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. The acid is multiplied by the number of moles of hydrogen ion yielded, and the base side is multiplied by the number of moles of hydroxide ion yielded. Now, if it's a monoprotic acid, no problems. H plus is a 1. If it's a monohydroxy base, no problems. OH minus is a 1. So let's just take a look. In this particular experiment, we said the molarity of the acid was the known, 0.1 molar. That's the standard solution. And the volume of the acid that we used was 10.0 milliliters, equal to the molarity of the base, which is our unknown, times the volume of the base that we used in the experiment. I'm going to make it up. I'm going to say it was 13.0 milliliters. This is what you observed in the experiment. Now, it's HCl. So there's only one hydrogen ion that's coming off here. And it's NaOH, so there's only one hydroxide ion coming over here. So solving that equation, and I'm going to use my calculator, 0.1 times 10.0 gives us 1 molar milliliter, which is equal to molarity of the base times 13.0 milliliter. How do you get molarity of the base alone? You're going to isolate the molarity of the base. So you're going to divide both sides by 13.0 milliliters. 13.0 milliliters. Cancel. Milliliter up, milliliter down. Canceled. So using your calculator, 1 divided by 13 is 0.076. My calculator is a little off, but it's 0.077 molar. Okay, I'm not following the rules for significant digits, just so that you know. We don't need to complicate the issue. So there is the math of titration. And the nice part about it is, if you recall, when we did dilution, we did mark that titration and dilution, well, molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. It is a very simple chemical formula, mathematical formula that we can use when we're talking about dilution, and now in the context of acid and base titration. So molarity of the acid is the H+. The volume of the acid, if it's in milliliters, keep it in milliliters. They're not usually going to push us to convert. Molarity of the base is OH minus, and the volume of the base, OH minus. So molarity of the acid times the volume of the acid is equal to molarity of the base times the volume of the base. It's under the titration equation on table T. Table T. So just reviewing, we would have done acid-base titration 2-3 times. And I want you to think about, and here's the secret question, think about why. Why would we have repeated these trials 2, 3, 4 times? What's the purpose of that? And why in science is that important? So now the next video, we're going to do a couple of calculations together, and then we'll move on from there.